What if the universe didn't truly begin with an explosion, but with something far gentler? An unfolding so soft and ancient that it felt more like the quiet bloom of a thought than the birth of space and time. That question lingers like a thin ribbon of starlight stretching across a dark horizon. It doesn't demand answers. It simply invites you to drift closer, to wonder how something as vast as the cosmos could emerge from a moment so delicate that even eternity seems to hold its breath remembering it. As you ease into the stillness around you, imagine the night settling softly against your skin, the air growing calmer, the world dimming into a warm, velvety quiet. Thoughts that felt sharp during the day begin to soften, drifting like slow-moving currents beneath the surface of a dark lake. Here, in this peaceful corner of the universe, there is nothing to chase, nothing to rush. You are safe, suspended in a gentle hush that seems to move with the same quiet rhythm as distant galaxies. The idea we explore tonight is both simple and staggering: how everything began. The Big Bang is often described as a dramatic flash, a sudden eruption of energy and space. But when astronomers study the faint afterglow of ancient light, those stretched, ghost-like traces in the cosmic microwave background, and when telescopes peer deeper into time than any human eyes ever have, the story grows more intricate. It becomes a tapestry woven with silence, expansion, uncertainty, and beauty. A beginning that might not be a single spark at all, but something older, wider, and infinitely more mysterious. If this calm journey through science brings you peace, or if these quiet explorations help your mind unwind, I am sincerely grateful to share this night with you. And if you'd like to help this gentle space reach other curious travelers, leaving a like and subscribing to the channel truly means a lot. Little gestures like that ripple outward, quietly keeping this sanctuary glowing for anyone who needs a moment of stillness. So let your breath settle, light and unforced, and imagine the universe just before its first shimmer of light. Picture a silence so deep it feels almost alive, holding within it every atom, every star, every possibility. As we drift toward that ancient threshold, you may sense that the story of the beginning is not what it first seems. Something subtle is waiting just beyond the edge of thought, ready to unfold. The earliest moments of the universe blur into something almost impossible to grasp, a kind of trembling potential suspended in darkness. Before stars, before atoms, before even the notion of before, there was a restless tension woven into the fabric of existence. It wasn't loud or dramatic. It felt more like a quiet urging, a shift in the stillness that would one day become everything we know. Trying to imagine it is like trying to recall a dream before it fully forms, vague, ancient, and strangely familiar. Physicists describe that early environment as unimaginably dense, where energy pressed so tightly against itself that nothing resembled matter yet. Equations written decades apart echo the same conclusion. The universe began in a state where distinctions didn't exist. No particles, no atoms, only pure energetic presence. As the cosmos expanded and cooled, the earliest hints of structure began to emerge. The idea is simple in theory, yet the reality is extraordinary. Everything around us once lived compressed into something far smaller than a grain of sand. If you try to give that era a shape, imagine a glowing haze so bright it seems to pulse softly, as though light itself is learning how to breathe. This wasn't light the way we know it. It was trapped, folded into the density, moving but never escaping like reflections trapped inside a polished gemstone. That softness feels strange to picture, something overwhelmingly energetic, yet wrapped in a kind of cosmic lullaby. Looking back at such a moment forces us to rethink what beginnings even mean. We tend to imagine beginnings as clean breaks, sharp sparks, or dramatic openings. But the universe's origin behaves more like a slow emergence, as if existence prefers to rise gently rather than erupt. In a way, this mirrors the patterns of our own lives. The most defining changes are often the ones that happen quietly, long before we're aware of them. Expansion is one of the first things the universe learned to do, not a violent outward thrust, but an internal stretching, space unfolding from within itself. It's difficult to wrap your mind around. Nothing moved through space because space itself was doing the moving. Wherever you stood, everything else would seem to drift away from you, not because you were special, but because this was happening everywhere at once. Modern astronomy simplifies this idea with an analogy involving a balloon dotted with tiny marks. As the balloon inflates, every mark drifts apart from every other mark, even though none of them are actively moving. It's the expanding surface that creates the distance. Galaxies behave in exactly that way today, not racing outward like shrapnel, but being carried by the stretching of space beneath them. If you imagine being one of those tiny marks, it would feel as if the space around you was slowly, steadily exhaling. Other dots recede, not urgently, but with a quiet determination. The sensation isn't one of motion, but of gentle widening, like the slow unfurling of morning light revealing more of the horizon. There's a kind of serenity in that widening, a reminder that even vast cosmic processes can feel calm. Thinking about expansion in this way encourages a different perspective. Instead of a blast, the universe resembles something blooming. Instead of a boundary, it feels like a transition. Instead of an event, a transformation. Maybe creation is less about abrupt appearances and more about gradual revelations, just as understanding dawns not in an instant, but in slow, expanding waves. One of the most puzzling clues about the early universe lies in its smoothness. When scientists map the faint microwave glow left over from the early cosmos, they find temperatures almost perfectly uniform across the sky. That's nearly impossible unless something extraordinary happened before the expansion we know, something that erased irregularities and smoothed out chaos with unbelievable speed. The explanation proposed for this smoothing is known as inflation, a period when space expanded faster than the speed of light. This doesn't violate physics, because nothing traveled through space faster than light. Rather, space itself stretched. Inflation flattens disturbances the way a sudden tug smooths a wrinkled sheet, leaving a vast, even field ready for the next stages of cosmic evolution. To visualize inflation, think of holding a small square of cloth. It's scrunched, rippled, uneven. Now imagine pulling it outward so quickly and evenly that the wrinkles vanish in an instant. What was once tangled becomes smooth and spacious. The universe, freshly stretched, resembled that expanded cloth, open, calm, and ready to be shaped by gravity and time. There's something deeply poetic about the idea that the universe began by being smoothed into stillness. For all the talk of explosions and chaos, the evidence points toward a moment of sudden quieting, an instant where noise became order. Perhaps the most astonishing events are not always loud. Perhaps creation sometimes begins with silence. As the universe continued to expand and cool, energy began condensing into the first particles. Quarks paired into protons and neutrons, and electrons flickered into being, like sparks rising from a forge. These weren't stable yet. They crashed, scattered, and merged constantly, but their presence marked the first hint that matter was possible. The cosmic heat was relentless, but slowly patterns began to settle. The laws guiding these particles were already in place, even in that early era. Gravity, electromagnetism, and the strong and weak nuclear forces each shaped how these tiny pieces behaved. The rules feel invisible, yet they choreograph the entire dance of existence with unwavering precision. the universe was still almost entirely energy. But the blueprint of every future atom, starry and planet was already encoded in the behavior of these forces. Try imagining this process not as chaos, but as a kind of shimmering choreography. Particles flash into and out of existence, drifting like glowing dust swirling through warm air. They collide gently, separate, reappear, dissolve. There's motion, but it's soft, like watching candle flames bend and twist without ever touching. Beneath the intensity lies something strangely peaceful. Moments like these reveal that beginnings often require both tension and patience. The universe didn't assemble itself in a single instant. It simmered, it waited, it cooled just enough for structure to form. Even in our own lives, we often misunderstand the slow work of foundation building. The groundwork for transformation is laid in periods of quiet becoming, not loud breakthroughs. Eventually, conditions grew calm enough for electrons to settle into orbit around protons, forming the first atoms, almost entirely hydrogen. With atoms finally stable, the universe turned transparent. Light, once trapped, was free to travel. The faint, stretched glow created during this moment still washes over Earth today, a 13-billion-year-old whisper drifting through space. Hydrogen may sound simple, but it is the universe's fundamental storyteller. Under gravity's persistent pull, hydrogen clouds grew denser, warming under their own weight until the first stars ignited. These early stars transformed the darkness, forging heavier elements in their cores and releasing them in brilliant waves. Everything complex, planets, oceans, living cells, even your body, began as hydrogen touched by gravity and fire. Imagine those first stars flickering into existence like embers, rising from a vast cosmic hearth. Their glow would have been faint at first, softening the darkness instead of piercing it. Even so, each new point of light marked a profound change. The universe, once uniform and shadowed, now held places of warmth, tiny islands of brilliance floating in a still expanding sea. Realizing this brings an unexpected intimacy to the story of creation. We are made of those first fires. The atoms forming your bones were shaped in ancient stellar furnaces. The calcium in your teeth, the iron in your blood, the oxygen you breathe, all born from stars that lived and died billions of years before Earth existed. The beginning of the universe isn't distant, it's inside you. As stars gathered into clusters, gravity sculpted them into the first galaxies. These early structures were small, fragile, often merging with others to grow. Over time, they became spirals, ellipses, and irregular forms, each carrying the fingerprints of ancient collisions and long tidal interactions. The Milky Way, our home, is one of their descendants, an echo of the early universe shaped by billions of years of motion. Galaxies drift through space with astonishing slowness, moving in grand arcs that take eons to complete. Their motion isn't frantic or directionless. It follows the quiet pull of gravity, guided by invisible dark matter halos. In the vast silence of space, their journeys feel more like drifting than traveling, as though they're carried on a gentle current of time. Picture a galaxy as a luminous leaf floating on a black ocean. It rotates gracefully, its stars tracing slow spirals like glowing breaths. Around it, other galaxies drift, merge and separate in long, dreamlike motions. Even in these enormous scales, there's a softness, a rhythm, proof that the universe prefers patterns of flow rather than abruptness. The more we learn about these early epochs, the more the concept of a single explosive beginning begins to dissolve. Instead of a sharp boundary, the universe feels like a story with chapters blending into each other, one phase easing into another with quiet continuity. Creation isn't a point, it's a movement. Some physicists propose that our universe may be one cycle in a sequence of universes, each expanding, contracting and giving rise to the next. Others suggest that time itself behaved differently before expansion, perhaps flowing in ways we cannot imagine. These ideas are speculative, but they highlight something profound. Our understanding of beginnings is still evolving. Try imagining the moment before the first expansion, a state without form, without dimension, without even the silence we understand. So if something existed, it must have been still in a way no human experience can match. And then a shift, not a roar, not a flash, just a transition, a quiet change in the fabric of what could be. Sitting with that thought draws the mind into a calm, spacious place. The universe stops feeling like an object and starts feeling like a process, one that moves with patience and purpose. In that sense, the beginning isn't something to grasp, but something to feel, as though it's still unfolding in the background of our own consciousness. Each step deeper into this story carries a subtle pull, as though something in those early moments is still calling to us across billions of years. The universe seems to hold one more secret just beyond the edge of understanding, waiting quietly for the mind to slip into the right stillness to hear it. Long after the first stars flickered awake, the universe continued shaping itself in ways both subtle and profound. The cooling of space allowed matter to gather more efficiently, turning scattered hydrogen into immense clouds that stretched for light years. These clouds didn't behave with urgency. They drifted, folded, and slowly responded to gravity's patient pull. Over millions of years, entire regions of space thickened like mist settling into valleys. It was here, in these quiet convergences, that the next great transformation began. Astronomers studying distant galaxies now see patterns that reveal how those early clouds condensed. Simulations performed on supercomputers show that dark matter, an invisible material we can't touch or see, acted like a hidden framework. Ordinary matter followed these invisible structures, gathering in their gravitational wells. Without dark matter, galaxies as we know them couldn't hold themselves together. Every star, every planet, every breath we take is nested within a structure shaped by something we still don't fully understand. Just imagine drifting through one of those early clouds, the darkness streaked with faint glimmers of forming stars. It would feel like floating through a deep ocean where light is soft, scattered, and rare. Temperature and pressure shift gently around you, as if space itself were breathing in slow, deliberate cycles. Nothing moves quickly, yet everything is changing. Shapes emerge, fold, collapse, and reform in a silent choreography too slow for human senses to detect. Moments like these reveal something meaningful about our universe. Creation rarely happens in bursts. Instead, it unfolds like a long exhale, revealing structure only when conditions are calm enough. It's a reminder that growth, cosmic or personal, often begins without spectacle. The universe built its most magnificent structures through patience, not haste, teaching us that time is not a barrier, but a collaborator. As clouds grew denser, their internal pressure increased. Eventually, certain regions reached a point where gravity overwhelmed all outward forces, triggering collapse. These collapses formed the second generation of stars, larger, brighter, and richer in the elements forged by the first. Each star lit its surroundings, carving out cavities in the darkness. Their ultraviolet radiation shaped nearby gas, forming pillars, ridges, and vast voids. Modern observatories like the James Webb Space Telescope capture these processes with breathtaking clarity. The Carina Nebula, the Pillars of Creation, and other stellar nurseries show us cosmic sculpting in real time. They are snapshots of what the early universe must have looked like, turbulent yet graceful, chaotic yet harmonious. The physics is fierce, but the visuals are soft, full of quiet drama. Picture standing inside one of these nebulae, though no human ever could, and watching starlight scatter across dust like fireflies swirling through fog. The colors would bleed gently into each other, blues fading into golds, reds melting into deep violet. Shadows stretch across vast distances, shaped by light that traveled thousands of years to reach you. Even turbulence feels serene at such scales. Beauty is not an exaggeration, it's the natural state of stellar birth. Moments like this make you realize that the universe creates complexity through layers, not leaps. Every star that forms becomes a furnace where new elements take shape. Hydrogen fuses into helium, helium into carbon, carbon into oxygen. These elements are the seeds of life, and they are born in the quiet heartbeats of stars. No explosion is needed for this stage, just steady, continuous fusion, glowing patiently in the dark. As stars matured, some grew massive enough to reshape their surroundings violently. Their nuclear furnaces burned through fuel in short, brilliant lifetimes. When they could no longer sustain fusion, their cores collapsed. The outer layers rebounded in a supernova, one of the rare loud events in cosmic history. These explosions scattered heavy elements across space, enriching future generations of stars and planets. Supernova remnants observed today reveal this process in exquisite detail. Expanding shells of gas glow in blues, greens, and reds, tracing shock waves that ripple outward for centuries. Each explosion plants the seeds for future solar systems. Without these colossal endings, Earth would never have formed, life would never have appeared. Even our thoughts right now are made from material once flung across the universe by a dying star. Try imagining a supernova from a safe, impossible vantage point. The star brightens suddenly, outshining its entire galaxy for a moment. Colors twist and swirl, as if fire and water were merging into one brilliant gesture. After the flash, the remnants expand like a slow-motion bloom of luminous smoke. Beneath the spectacle lies a quiet truth. Endings give birth to beginnings on a cosmic scale. There's something deeply human about that idea. We often fear collapse, forgetting that collapse clears the way for renewal. The stars remind us that destruction and creation are bound together. Nothing truly disappears. It transforms, travels, and eventually takes on new form. Even the atoms in your skin were scattered by ancient supernovae long before Earth existed. Over time, the enriched gas settled again into new clouds, forming new generations of stars and eventually planetary systems. Among these systems was a modest yellow star in an unremarkable arm of a spiral galaxy. Around it, dust swirled into rings, clumping into protoplanets that collided, fused, and slowly grew. One of them would cool enough to hold oceans. Another would grow large enough to become a gas giant. The smaller one, glowing red from constant impacts, would one day become Earth. These planetary disks are visible today around young stars. Telescopes reveal rings like grooves on a record, carved by growing planets. Shadows stretch across the disks, marking where worlds are forming. Watching them feels like witnessing time itself sculpting reality. Everything we have, mountains, rivers, memories, began as dust swirling around a newborn star. If you picture drifting through one of those protoplanetary disks, you'd see grains of silicate and ice glinting like tiny fragments of frozen sunlight. These grains collide gently at first, sticking together through static electricity, then gravity. With time, they grow into pebbles, rocks, mountains, and eventually worlds. It's a slow, almost meditative process, shaped by chance and physics in perfect balance. What emerges from all this is a universe that builds complexity from simplicity. Hydrogen becomes stars. Stars create elements. Elements form planets. Planets cradle life. At every stage, The universe seems to lean toward structure, toward depth, toward possibility. It's as if the cosmos carries an instinct for becoming. And as these new worlds form, the universe continues expanding in the background, its quiet stretching never stopping, its rhythm never breaking. Galaxies drift farther apart, space grows colder, light stretches into longer wavelengths. Yet within this slow cooling, life finds a way to kindle warmth. Consciousness arises, curious and fragile, wondering how all of this began. Thinking about this, you may feel a soft shift inside, the realization that the universe hasn't stopped telling its story. You are living inside one of its chapters. The atoms forming your thoughts were forged in ancient furnaces. The air filling your lungs once drifted between stars. You're not separate from this narrative. You're woven into it. And as we move deeper into this long cosmic story, there is another layer waiting. One that challenges our assumptions about the beginning itself. Something subtle, something quiet, something older than the Big Bang as we usually imagine it. It lingers just beyond the edges of what we've explored so far, waiting for the moment when curiosity grows still enough to approach it. When you follow the timeline of the universe back to its earliest measurable moments, you eventually reach a boundary, an edge in the equations where our laws of physics no longer behave. This boundary is not a wall, but a blur, a place where time and space become so tightly intertwined that they lose their familiar meanings. Scientists call this the Planck era, a fraction of a second after the beginning, where everything we understand becomes uncertain. It is the closest we can mathematically approach the origin. Studying this era requires theories bold enough to handle gravity and quantum mechanics simultaneously. General relativity describes the universe at large scales, while quantum mechanics governs the tiny, jittering world of particles. But at the Planck scale, these two frameworks collide. Gravity becomes quantum, space-time becomes grainy, and certainty dissolves. Every attempt to unify these forces reveals glimpses of a deeper structure, something underlying both formulas and intuition. The universe becomes a place of possibilities rather than specifics. Imagine space-time at that scale as a shimmering mesh, constantly fluctuating, folding, twisting, and rearranging itself. There are no separations, no clear distances, no direction. Up and down lose meaning. Before and after blend. The familiar fabric of the cosmos resembles a restless ocean of probability. Waves of potential rise and fall without pattern, like moonlit ripples on a lake stirred by no wind. Nothing stays still long enough to define it. When you sit with that image, it becomes clear that the idea of a clean, sharp beginning is more an artifact of human storytelling than a reflection of physical reality. We prefer origins to be clear and bold because they help us feel grounded. But the universe, especially at its earliest moments, doesn't behave that way. It prefers gradients, transitions, subtle dissolves, beginnings that feel more like dawn than ignition. Some theories propose that before the universe expanded, it may have collapsed from a previous state. In this view, everything we know could be the rebound of a prior cosmos. Instead of a single beginning, there might be cycles that stretch across unimaginable epochs. Expansion becomes contraction. Contraction becomes expansion, like breathing on a scale so vast it's nearly indistinguishable from eternity. The Big Bang then becomes a turning point rather than a birth. Models like the bouncing universe, loop quantum cosmology, and ekpyrotic scenarios all suggest that the so-called beginning may not be the beginning at all. They describe a cosmos that avoids singularities by compressing into a minimum volume and then re-expanding. The mathematics behind these ideas hints at something remarkable. The universe might be older than the Big Bang itself, older than space, older than time as we measure it. Envision a cosmic cycle as immense tides rising and falling over spans longer than any number we normally use. Entire universes might blossom and fade within a rhythm too slow to perceive. If this is true, the faint whisper of the Big Bang is not the first note of creation, but simply one verse in an immeasurable song. It's a comforting idea, one that replaces finality with continuity. From another angle, quantum cosmology suggests that the universe could have emerged from a state with no classical time at all. In that primordial timelessness, reality existed as pure possibility. Time might have crystallized only once expansion began. Before that, before didn't exist. It's a strange idea, but it fits the math. Time is not fundamental, it's emergent, like a melody that appears only when an instrument is played. Picture that timeless state as a stillness so complete that even silence feels too noisy a word. No ticking, no flowing. Just an unbroken presence containing every potential outcome. When expansion began, time began to flow, like a stream forming from the melting of ancient ice. The universe didn't start, it transformed, shifting from potential to expression. Ideas like these remind us that our intuition is shaped by experiences on Earth, not by the nature of the cosmos. We expect beginnings to resemble birth and endings to resemble death. But the universe may not follow these patterns. Its origins might be circular, branching, or layered in ways we aren't built to instinctively grasp. Still, even partial understanding brings a deep sense of awe. One of the most fascinating proposals suggests that quantum fluctuations could have triggered the universe's expansion. No tiny fluctuation in a pre-existing vacuum could, given the right conditions, blossom into an entire cosmos. This isn't random chaos, it follows specific rules. Virtual particles appear and vanish constantly in quantum fields. If space was once in a metastable state, a small fluctuation could have tipped it toward expansion on a massive scale. Scientists compare this process to bubbles forming in boiling water. Each bubble represents a region where conditions changed enough to create a new phase. If the vacuum of space behaved similarly, our universe could be one such bubble. Others might exist elsewhere, expanding into their own infinities. We would be one bubble among countless others, drifting silently through the dark sea of a larger reality. Imagine floating inside such a bubble universe. The edges stretch outward faster than anything inside can reach. Light can travel forever, yet never touch the boundary. Space itself balloons out, carrying galaxies like lanterns drifting in a slow, endless tide. The thought is strange, yet strangely comforting. Our universe is vast, but maybe it's also part of a greater landscape, each region a quiet experiment of physics. If this is true, the Big Bang wasn't the beginning. It was simply the moment our bubble separated from the field that birthed it, a transition rather than a start. And transitions can be gentle, almost tender. A slight shift, a small imbalance, the faintest tilt that leads to everything. It's a reminder that entire worlds can arise from subtle changes. Then there is the holographic perspective, which proposes that our universe might be a projection of deeper physics, occurring at a boundary we can't directly observe. In this view, the Big Bang could reflect a transformation on that unseen surface. Space, time, and matter might be emergent illusions, expressions of something more fundamental. If so, the beginning isn't a moment in time, but a shift in the underlying information that encodes reality. Thinking about the universe this way is like imagining a vast tapestry where every thread holds meaning. The visible fabric is only the outermost layer. Beneath it, patterns continue in directions we can't see. What appears as a beginning from the inside might be nothing more than the start of a new weaving pattern in a larger loom. Ideas like these can feel overwhelming at first, but they also carry a quiet beauty. They suggest that the universe may be deeper, older, and more intricate than any single theory can describe. Instead of narrowing our view, they widen it, allowing us to breathe a little more deeply into the mystery. Scientific models are attempts to translate strangeness into understanding, but some aspects of the universe resist translation. They remain beyond equations, shimmering at the edge of comprehension. That shimmering is not a failure, it is the source of wonder. The cosmos invites us to explore, not to conquer, to listen, not to demand clarity. The beauty of this uncertainty is that it keeps curiosity alive. If we knew everything about the beginning, the universe would feel smaller. But the gaps in our knowledge leave space for imagination, for humility, for awe. They remind us that we are participants in a story still unfolding, not observers who stand apart from it. When you sit with these possibilities long enough, the question, did the universe really begin with the Big Bang, becomes less about finding a single answer and more about appreciating the vast spectrum of what could be. The beginning may be more subtle than any narrative we've created. It may be layered, recursive, or perpetually renewing. Letting that uncertainty settle is strangely calming. You don't need to solve it. You only need to feel the scale of it, the quiet vibrancy of a cosmos weaving itself moment by moment. Some truths are too spacious to hold tightly. They must be approached the way you approach sleep, gradually, gently, without forcing clarity. As these ideas sink in, something else begins to glow through the haze, another possibility, older than the ones we've explored so far. It waits in the background like a soft resonance, ready to reveal itself when the mind relaxes enough to follow the next thread of the cosmic story. Long before galaxies matured into the grand spirals we admire today, the universe entered a period of delicate transformation. Temperatures continued to drop, allowing previously turbulent regions to settle into calmer forms. This cooling didn't happen evenly. Some areas thickened more quickly, others remained diffuse. Over hundreds of millions of years, these tiny imbalances grew, giving rise to the vast cosmic web that stretches across the universe. What began as subtle variants evolved into the grand architecture of everything we see. Astronomers map this cosmic web using gravitational lensing and deep surveys, revealing strands of matter threading through space like luminous filaments. Between them lie enormous voids, regions almost entirely empty, silent expanses where matter never gathered. These voids are not mistakes, they're integral to the structure. The universe, for reasons encoded in its earliest fluctuations, preferred a pattern that resembles living tissue more than rigid machinery. It's a design shaped by both chance and law. Staring at a visualization of this web feels like peering into a living organism. The strands branch, merge, twist, and glow faintly at their densest intersections. Imagine drifting along one of these luminous rivers of matter, watching stars scatter like sparks from a distant fire. The emptiness around you feels deep, but not frightening, more like a vast room lit by faint lanterns along a distant wall. Patterns like these hint at the quiet intelligence of natural processes. No conscious architect shaped the cosmic web. It emerged from simple rules repeated billions of times over billions of years. Order arises not from intention, but from inevitability. Even when nothing seems deliberate, harmony still appears. The universe leans toward structure the way rivers carve valleys, slowly, persistently, without needing permission. As the web matured, galaxies began migrating along its filaments. Gravity pulled them toward regions of higher density, forming clusters and superclusters. These environments became some of the most active locations in the cosmos, where galaxies interacted, merged, and cannibalized each other in long, graceful collisions. Despite the violence of the process, The motion is so slow that if you watched it in real time, you'd swear nothing was happening at all. Researchers studying these interactions observe how mergers can trigger bursts of star formation. When two galaxies pass through each other, their gas clouds compress, igniting waves of new stars. The process is like striking flint. Friction creates light. Entire generations of stars are born from these encounters, each one carrying the elemental legacy of the galaxies that collided to create it. Picture one such collision from an impossible vantage point. Two luminous shapes glide toward each other, their spiral arms stretching like fingertips. As they overlap, stars pass by without touching, so distant from their neighbors that collisions almost never occur. Yet gas clouds slam together, sending ripples of brightness rolling through the darkness. It's like watching two slow-moving oceans merge into a single glowing sea. Moments like this reveal a truth about creation. Sometimes growth requires entanglement. Galaxies don't evolve in isolation. They stretch, collide, exchange, and transform, leaving behind forms richer than what existed before. It's a pattern mirrored in countless aspects of life. Connection, even when messy, often leads to beauty. Over time, galaxy clusters shape the large-scale environment of the universe. Their gravitational pull sculpted the motions of nearby systems and influenced the flow of matter for millions of light years. At the center of many clusters sits a massive elliptical galaxy, swollen by countless mergers. These giants serve as quiet anchors, holding gravitational sway over entire cosmic neighborhoods. Observations reveal that these central galaxies often contain supermassive black holes billions of times the mass of the Sun. Far from being destructive interruptions, these black holes regulate star formation by controlling the temperature of surrounding gas. Jets of high-energy particles stream from their poles, creating cavities and shock waves that ripple through the cluster. Instead of tearing the environment apart, they maintain balance. Imagine hovering near one of those jets, watching particles race past at nearly the speed of light. The surrounding gas glows faintly from the energy pumped into it, like embers stirred by a sudden breeze. The black hole itself remains invisible, yet its influence shapes everything around it. It's a paradox, darkness sculpting light. Reflecting on this, you start to sense that the universe doesn't divide creation and destruction the way we do. What seems catastrophic at one scale becomes nurturing at another. A black hole feeds on matter, yet sustains galaxies. Collisions tear shapes apart, yet spark new stars. Change is neither good nor bad. It's simply the rhythm of existence. As clusters grew more massive, they began interacting with one another. Entire regions of the cosmic web shifted, slowly bridging neighboring superclusters. These connections created colossal structures spanning hundreds of millions of light years. The Sloan Great Wall, the Hercules Corona Borealis Great Wall, names barely large enough to describe the scale. They are the grand highways of the cosmos. Mapping these structures challenges our understanding of cosmic evolution. Their size seems almost too large to form in the time since the universe began expanding. Yet there they are, immense, intricate, ancient. Each one whispers that the universe may hold surprises even within the laws we already know. Patterns emerge at scales so vast, they feel more like myth than measurement. Try to imagine traveling along one of these colossal highways. Galaxies drift by like lanterns floating on an endless tide. The darkness between them feels soft, almost warm, as though cradling each glowing system in a gentle embrace. You wouldn't sense motion. Everything moves too slowly. Time stretches out, becoming wide and quiet. Thoughts like these make the universe feel less like a cold expanse and more like a living, breathing presence. Its structures resemble growth rings, branching limbs, and neural pathways. The cosmos doesn't simply exist, it evolves. With each passing eon, it rearranges itself into forms more elaborate, more interconnected, more alive. Dark matter continues to play a central role in all this. Its invisible pull threads the cosmic web together. Without it, filaments would unravel, clusters would disperse, and galaxies would drift apart without direction. The ordinary matter that forms planets, oceans, and people is merely the surface texture of a deeper and unseen foundation. Scientists attempt to detect dark matter directly through underground experiments and particle accelerators. So far, it has eluded capture, yet its gravitational fingerprints are unmistakable. Every rotation curve, every lensing arc, every simulation points to its presence. It hides in plain sight, not through trickery, but through nature's decision to work with more layers than we can currently perceive. Thinking about dark matter feels a bit like sensing a presence in a quiet room, a presence you can't see but can clearly feel. You don't need to touch it to know it's there. Its influence shapes the room, rearranges the air, changes the way sound echoes. In the same way, dark matter shapes the cosmos without revealing its face. This mystery softens the boundaries of understanding. It reminds us that knowledge is not a static destination, but an unfolding. Every discovery opens a doorway to something deeper. The more we learn, the more the universe expands, not just physically, but conceptually. Wonder grows alongside knowledge. Dark energy presents an even stranger puzzle. While dark matter draws galaxies together, dark energy pushes them apart. It's the engine of accelerating expansion, a force embedded in the fabric of space itself. Observations of distant supernovae revealed that cosmic expansion isn't slowing, it's speeding up. Something unseen is driving everything outward, gently but relentlessly. Visualizing dark energy is challenging because it doesn't behave like anything familiar. Rather than pushing from one place, it seems to stretch space uniformly, like a quiet tension infused into the vacuum. Imagine a sheet of soft fabric slowly expanding in every direction without anyone touching it. The movement is smooth, almost shy yet persistent. This slow widening creates a subtle melancholy. As expansion accelerates, galaxies drift farther from each other. Some will eventually disappear beyond visibility, not because they fade, but because space between us grows faster than light can travel. The universe isn't falling apart, it's drifting apart. A gentle separation, written into the future. There's something poetic in that separation. Connections form, evolve, and slowly stretch with time. Nothing stays still forever. Even the grandest structures loosen their bonds. Yet the beauty remains in the motion itself, not in trying to freeze it. The universe's story is one of letting go as much as becoming. For all these complexities, the deeper pattern becomes clear. The cosmos is not static. It is an unfolding, a vast choreography shaped by gravity, expansion, invisible matter, and unseen energy. Every structure, from galaxies to clusters to the cosmic web, emerges from this interplay. The universe is a process, not a place. Sitting with this idea awakens a quiet sense of belonging. If everything is in motion, then so are we. Our thoughts, our stories, our lives, each one part of the same slow unfolding. The universe doesn't ask for certainty. It asks for openness. It invites us to drift, observe, and let the mystery settle around us like a soft glow. And somewhere within this vast tapestry lies a clue, one that pulls us closer to the truth of how the beginning might be far more intricate than the standard story suggests. There is a pattern hidden in the early expansion, a gentle anomaly waiting to be unraveled as we continue deeper into the universe's quiet origins. Certain ideas in cosmology sit at the intersection of science and wonder, and one of them revolves around the nature of time itself. When we look far enough into the past, time begins to behave strangely. It doesn't stretch backward infinitely in the simple, linear way we experience daily. Instead, it curves, folds, and shifts depending on energy, gravity, and quantum mechanics. Asking what happened before the earliest moments becomes a fragile question, because the concept of before dissolves at extreme scales. Research on time's behavior near the earliest epochs leads physicists to equations where time becomes intertwined with space in ways that defy intuition. In general relativity, time slows near intense gravitational fields. In quantum mechanics, it loses its continuity and appears in discrete, jittery packets. Combining these frameworks suggests that the first instant was not a moment inside time, but a phased transition from a timeless state to one where temporal flow began. Contemplating this transition feels like imagining dawn without a night preceding it, light emerging without the contrast of darkness. It's a moment with no boundary, no edges, no separation. More like the soft bloom of color across the horizon before the sun appears. There is no before. There is only the gradual unfurling of what time would eventually become. That idea gently nudges us toward humility. It reminds us that even our most fundamental concepts, time, direction, sequence, are local impressions shaped by our narrow experience. The universe may operate with a deeper rhythm, one that doesn't rely on the linear progression we're accustomed to. In that sense, understanding the beginning becomes not a matter of looking backward, but of letting go of assumptions. Another layer of the mystery arises from the cosmic horizon, an invisible boundary beyond which we cannot observe. Light from regions farther than that hasn't had enough time to reach us since the universe began expanding. This horizon is not an absolute edge. It's simply the limit of what the speed of light and cosmic expansion allow us to see. Anything beyond remains hidden, not by distance alone, but by the very fabric of space. Observations from ESA's Planck satellite show minute temperature variations in the cosmic microwave background, offering a map of what lies within our observable patch. But beyond that, we can only infer possibilities. The unobservable universe might be similar to our own, or radically different. It might stretch infinitely, or loop back on itself in ways geometry alone cannot explain. Our cosmic neighborhood is vast, but still just a neighborhood. Imagining that hidden expanse is like standing on a quiet shoreline, aware that an entire ocean stretches beyond the darkness, but unable to see its waves. The horizon glows faintly, not from light, but from the knowing that more exists. You sense its presence the way you sense the weight of deep water beneath your feet. Vast, unseen, but undeniably real. This horizon problem is one of the key motivations behind inflation theory. Without inflation, regions on opposite sides of the sky would never have been in contact early enough to share temperature information, yet they appear almost identical. Inflation stretches space so rapidly that regions once close become vastly separated. The uniformity we observe today becomes a relic of a time when the universe was compact and connected. Those insights lead to another strange thought. The region we see is just a fragment of a much larger structure. Inflation could have magnified a tiny portion of pre-existing space, turning a microscopic patch into everything we now observe. If so, the true scale of the universe might be far beyond what the observable horizon implies. Our cosmic perspective could be no more representative of the whole than a grain of sand is of an entire desert. Trying to visualize this scale is overwhelming. Think of drifting through a night sky where the darkness extends without repetition, no matter how far you travel. Stars fade behind you, yet the void persists, vast, quiet, untouched. The universe seems to whisper that scale is not a barrier but a canvas, painted with distances beyond comprehension. Within these frameworks, the Big Bang resembles less a beginning and more a boundary between two modes of existence. A quantum-dominated phase transitioning into a classical, expanding cosmos. It's comparable to water freezing into ice, not a creation of molecules, but a change in their arrangement. What we call the Big Bang could be the universe cooling into a form where space, time, and matter can exist coherently. This reinterpretation shifts the emotional tone of the beginning. Instead of imagining an explosive flash that birthed everything, we picture a soft crystallization, a settling of fundamental fields into patterns stable enough for physics to operate. The formation of time, space, and matter becomes not a violent origin, but a delicate rearrangement, like frost forming quietly along a window pane. Such shifts in perspective allow room for deeper reflection. When we release the need for a sharp beginning, the universe feels less like an object that popped into existence and more like a process unfolding through timeless phases. Creation becomes less about emergence from nothing and more about transformation from states we barely understand. Quantum fields offer another illuminating angle. In modern physics, empty space is not empty at all. It seethes with activity, fields vibrating with virtual particles popping briefly into existence before vanishing. If the universe began in a high-energy vacuum state, then the expansion we call the Big Bang may have been triggered by a shift in this vacuum. Reality didn't erupt, it rearranged itself. Physicists sometimes compare this to phase transitions in everyday substances. A superheated liquid can remain stable until a small fluctuation triggers sudden boiling. A supercooled liquid remains liquid until a tiny disturbance freezes it instantly. In the same way, the early vacuum of the universe may have been primed for change, needing only the faintest nudge to cascade into expansion. Imagining such a transition evokes the feeling of a quiet room where everything seems still. Yet beneath the stillness lies a tension so delicate you barely sense it. Then, with no obvious signal, the atmosphere shifts. The silence deepens. Something has changed, even if you can't see it. That moment, subtle, inevitable, captures the essence of cosmological phase transitions. Beyond physics, there's a philosophical weight to these ideas. If the universe emerged from a rearrangement rather than a creation ex nihilo, then the cosmos might be part of an eternal framework, a deeper reality where states shift but nothing truly begins or ends. Existence becomes cyclical, layered, continuous, boundaries blur. Letting that sink in evokes a strange kind of peace. You realize that the universe doesn't need a beginning to be meaningful. It doesn't need a sharp boundary to inspire awe. The beauty lies in the unfolding, not in the origin point. Like a melody that feels infinite even though it began somewhere, the universe carries the impression of timelessness regardless of its actual age. Some cosmologists even propose that what we call space-time could be emergent. Under this view, geometry itself is not fundamental, but a large-scale behavior of microscopic information. Time, distance, and direction arise from deeper rules we have yet to uncover. The Big Bang becomes not a singularity, but a shift in the underlying informational structure that gives rise to space-time itself. Visualizing this is like imagining a tapestry where the visible pattern is just one of many layers woven together. Pulling one thread reveals others beneath. The universe might be a projection of deeper interactions, each layer influencing the next. The beginning becomes a change in weaving technique rather than the start of the fabric. As these concepts accumulate, they build a quiet crescendo of wonder. Not because they provide answers, but because they reveal how much remains hidden. The deeper we look, the more we sense the presence of something uncharted beneath the surface of reality. A depth that humbles, not intimidates. Sitting with this mystery invites stillness. The mind stops reaching for certainty and starts welcoming possibility. You begin to see the universe as an evolving story, not a solved equation. Its beginning is not a closed door, but an open horizon, expanding with every question we dare to ask. Somewhere woven into these ideas lies a clue, one that doesn't shout, but murmurs softly, pulling attention toward the next layer of the story. It's a subtle shift in how we perceive origins, hinting that what we've explored so far is only the outermost skin of something far richer, waiting quietly in the dark. Deep within the earliest fractions of cosmic history lies a region so mysterious that language begins to fracture the moment we approach it. Our words were shaped for forests, oceans, and human emotions, not for conditions where space-time folds upon itself like trembling silk. Even so, physicists try to translate those primal moments into mathematics, and every new equation reveals an even older strangeness beneath the surface. Some ideas propose that space might not be continuous. Instead of a smooth landscape stretching infinitely, it may consist of tiny, discrete units, quanta of volume and area that form the scaffolding of reality. At scales far smaller than atoms, space might flicker in finite steps, not flowing seamlessly but ticking softly like gears in an unseen mechanism. Visualizing this granular structure feels like imagining a musical note composed of countless microscopic pulses. Each pulse is too small to detect, yet together they form something smooth and resonant. If space truly behaves this way, then what we perceive as continuity is simply our minds smoothing over countless quantum beats, like blending individual frames into a moving picture. Such a possibility reshapes the meaning of beginning. If space-time comes in discrete packets, then the earliest moment was not the birth of something from nothing, but the appearance of the first quantum of space, a shift in a system that previously had no geometry at all. The beginning wouldn't be explosive, it would be incremental, like the quiet click of a lock turning. Another thread in modern cosmology explores the idea of phase transitions shaping the earliest state of the universe. Rather than emerging from a single, compressed point, the cosmos may have shifted from one quantum configuration to another. Similar to water freezing or melting, this transformation could have occurred without a dramatic birth, simply a change in the rules governing reality. Thinking about the Big Bang as a phase transition softens its edges. Instead of a cosmic fireball, picture a field of energy reorganizing itself, settling into a new pattern that allowed space, time, and particles to appear. The beginning becomes a gentle shift in alignment rather than a violent eruption. Researchers who model these early fields often encounter spontaneous fluctuations, tiny disturbances arising within a seemingly uniform state. These fluctuations grow as the universe expands, ultimately forming the scaffolding upon which galaxies and clusters will develop. What appears random at first becomes the fingerprint of future structure. Imagining these fluctuations is like watching ink swirl through water. Thin strands stretch outward, twist and blend with others. Some patterns vanish instantly, others linger, gaining form as the liquid moves. No guiding hand shapes them, yet complexity appears naturally as the dynamics unfold. From these tiny variations, the bones of the universe emerged. Regions slightly denser than their surroundings attracted more matter, forming cosmic filaments and clusters. Regions slightly thinner became the vast voids we observe today. What we call structure is the magnified whisper of ancient quantum tremors. A different concept imagines the early universe as a roiling foam of space-time, where miniature universes formed and evaporated faster than light could cross their boundaries. This foam filled the primordial state, bubbling with attempts at existence. Most collapsed immediately. One bubble expanded, ours. Visualizing that foam feels like observing bubbles rising in a simmering pot, each one swelling briefly before fading away. Every so often, one grows large enough to persist. That survivor becomes a world. Our universe may be that rare bubble that refused to vanish. Once expansion began, everything changed. Space stretched faster than any particle could move, scattering the seeds of structure across unimaginable distances. The earliest events, once compressed into a microscopic volume, became smeared across billions of light years. Yet within that vastness, every tiny fluctuation continued guiding the evolution of galaxies. The scenario echoes the way thoughts appear in the human mind. Many arise and dissolve instantly, barely noticed. Once in a while, however, a thought persists, growing, spreading, defining the next moment of awareness. Perhaps the universe is similar, a fluctuation that survived long enough to become everything. Under this perspective, the Big Bang transforms from a point-like origin into a threshold, a boundary between two different states of reality. Before the threshold, nothing familiar applies. After it, the rules governing matter, light, and time take shape. The transition itself remains indescribable, much like the fleeting moment between dreaming and waking. Physicists often point out that our current equations fail precisely at this threshold. They were built for a universe already expanded, already cooled, already structured. They cannot faithfully describe the quantum storms of earlier states. Thus, the Big Bang marks not a beginning, but the limit of what our present theories can still articulate. Some models argue that the density of the early universe never reached infinity. Instead, it approached a maximum value determined by quantum effects. The earliest state becomes a plateau rather than a point, a region dense, finite, and transformable. This replaces singularity with stability and allows the universe to evolve smoothly into expansion. Other proposals describe the universe as a rare event, a low probability fluctuation permitted by the deeper rules of quantum existence. Nothing supernatural is required. Improbability alone is enough. The universe could be the statistical equivalent of a miracle that obeys all laws, yet happens only once in an ocean of unremarkable possibilities. Letting that notion settle invites a sense of quiet awe. Our existence might be the consequence of a single fluctuation that didn't fade, a brief tremor in an ancient field that grew instead of collapsing, a cosmic coin toss that landed upright instead of falling flat. Unlikely, yes, but not impossible. It's also possible that multiple perspectives are simultaneously true. The universe could be a bubble in a quantum foam, emerging from a phase transition, structured by discrete quanta and governed by probabilistic rules all at once. These frameworks don't necessarily contradict each other. They describe different layers of the same enigmatic process. Recognizing this layered nature adds depth to the mystery. The cosmos doesn't owe us simplicity. It doesn't have to follow a single narrative. It can be multifaceted, sprawling, intricate in ways that escape every metaphor we attempt to apply. Its complexity is not chaos, it's richness. The beauty of this realization lies in allowing the universe to remain vast. We don't need a definitive answer to appreciate its origins. The absence of finality doesn't diminish meaning, it expands it. The beginning becomes a tapestry rather than a point, a convergence of possibilities woven into reality. Sitting with these ideas creates a peculiar calm. Not the calm of resolution, but the calm of openness. You're no longer trying to force the cosmos into one explanation. You're letting it unfold the way it naturally does, slowly, intricately, with boundless patience. As the mind adapts to this expanded view, a subtle thread begins to shimmer through the complexity. It hints at a deeper insight, something older than any theory we've touched so far. Whatever it is, it waits quietly, almost expectantly, just beyond the next turn in the universe's unfolding story. Strange as it sounds, the universe could have followed entirely different rules. The laws of physics we take for granted, gravity's pull, electromagnetism's glow, the nuclear forces binding particles, were not guaranteed. They emerged from conditions in the early universe that could easily have unfolded another way. A tiny difference in the earliest instance could have led to a cosmos with no atoms, no stars, no complexity. The fact that our laws settled into such stable patterns feels almost miraculous, though nothing supernatural is required for that sense of wonder. Modern physics suggests that symmetry once governed everything. Particles shared properties, forces blended indistinguishably, and reality was more unified than it is now. As the universe cooled, these symmetries fractured like ice cracking into patterns across a frozen lake. Each break created new distinctions, different particles, separate forces, and the physical constants we observe. These symmetry breaks were subtle, but they decided the universe's fate long before galaxies existed. It helps to imagine symmetry as a single, harmonious tone. As the universe expanded and cooled, that tone split into chords, each representing a different force: gravity's curve, electromagnetism's shimmer, the strong force's binding, the weak force's delicate instability. The separation wasn't chaotic, it was structured. Guided by the mathematics encoded in quantum fields, the cosmos went from a single note to a full cosmic harmony. Thinking about these transitions feels like watching a painting come to life. At first, the canvas holds only one color, a uniform glow. Slowly, faint shades emerge, branching into textures, outlines, and contrasting hues. Nothing is added. The original color simply unfolds into complexity. The laws of physics emerge the same way, with subtle variations revealing themselves as the universe cooled. One of the most intriguing clues from this era involves matter and antimatter. According to the equations, they should have existed in equal amounts at the beginning. Yet our universe contains overwhelmingly more matter. This asymmetry is essential. Without it, everything would have annihilated into pure light. Something in the early universe created a slight imbalance, a tiny preference that allowed matter to survive and form stars, planets, and eventually us. Experiments at particle accelerators reveal hints of this bias. Certain particles decay in ways that slightly favor matter over antimatter. The preference is minuscule, yet over cosmic scales, such a difference shapes the entire universe. A fraction of a percent was enough to decide whether existence would be luminous and structured or eternally sterile. Imagining that imbalance is like imagining two tides rising simultaneously. If they were perfectly matched, they would cancel each other out completely. But introduce the smallest difference, barely noticeable, and one tide slowly overwhelms the other. The ocean changes, shorelines change. Entire landscapes arise or disappear. The early universe carried just such a quiet tilt. Reflecting on this delicate bias brings a softer understanding of creation. Sometimes the most profound outcomes come from subtle imperfections. Perfection cancels itself out. Imbalance creates motion. The universe did not emerge from symmetry. It emerged from symmetry's slight surrender. A tiny deviation made room for everything. As expansion continued, the cosmic soup of particles settled into more stable forms. Quarks combined into protons and neutrons. neutrinos streamed freely through space, and photons scattered without restraint. The universe became transparent enough for light to begin its eternal journey. The physical constants we know, like the speed of light, the charge of the electron, the mass of the proton, locked into place during this era. Physicists often wonder why these constants have the values they do. A small change in any of them would create a universe inhospitable to complexity. Too strong a gravitational constant, and stars collapse instantly. Too weak, and they never ignite. A slight change in electromagnetism and atoms could not form. The cosmos seems fine-tuned, not by intention, but by consequence. The concept of fine-tuning invites both awe and hesitation. On the one hand, the precision is staggering. On the other, the multiverse hypothesis suggests that countless universes may exist, each with different constants. In such a landscape, our universe simply happens to be one where the conditions support complexity, not chosen, just possible. Picturing the multiverse is like imagining a vast meadow blanketed with seeds. Only a few seeds land in the right combination of soil, temperature, and moisture to sprout. The rest remain dormant or perish. Each universe is a seed. Ours just found fertile ground. The rarity doesn't diminish the wonder. If anything, it deepens it. The emergence of constants, symmetry breaking, and matter dominance all contribute to a central realization. The early universe was extraordinarily sensitive. Every shift mattered. Every fluctuation echoed outward through billions of years. The cosmos carries the memory of those early decisions, like a faint resonance in its structure. This sensitivity suggests that beginnings are less like singular points and more like branching trails. At the earliest instance, countless paths could have unfolded, yet we inhabit only one of them. Our universe is a story selected from an unimaginable library, not by choice, but by the quiet direction of physics settling into form. Such an idea casts existence in a new light. Instead of being accidental or predetermined, it feels like an emergent expression, neither random nor designed, a delicate interplay of chance and law, something that arose because it could, not because it must. There's serenity in that balance. As the laws solidified, the universe transitioned into an environment where particles could interact according to stable rules. Stars would eventually ignite under these rules, galaxies form, black holes rotate, planets assemble. Everything familiar is built upon that early scaffolding. The choreography of the cosmos was written not in advance, but in the cooling, shifting, settling of those first instants. Thinking about this evokes the feeling of standing in a quiet room after a storm has passed. The air is still charged with memory, yet the world is settling into shapes that will last. Creation feels less like a bang and more like a slow exhale that has only just begun to fade. Some theories question whether these constants might still be changing today, though at rates too slow for us to detect. If they do shift, even subtly, the cosmos could evolve in ways far beyond our imagination. A universe that seems stable might be flowing through deeper phases we haven't yet recognized. Letting your thoughts drift over this possibility adds a layer of reverence. What we see as permanent may be transient. What feels fixed may be evolving. The universe may be adjusting its own rules in ways we are only beginning to sense, like a melody subtly shifting its tempo over a long, drifting night. What stands out through all of this is how creation depends on transitions, not absolute beginnings. The universe is shaped by gentle tilts, broken symmetries, fluctuations that persist, and constants that settle into place. Its story is not one of singular birth, but of continuous becoming. As the complexity of these ideas settles in, another quiet possibility begins to take shape, one that hints that the universe's origin might not lie in physics alone. Something deeper, perhaps woven into the fabric of information itself, waits just beneath the surface, ready to emerge as we continue drifting deeper into the cosmic story. It becomes increasingly difficult to discuss the universe's earliest moments without touching on the nature of information itself. Modern physics often suggests that information is not just a description of reality, it may be one of its fundamental ingredients. Every particle, every field, every fluctuation carries encoded details about its past interactions. Nothing is ever truly lost, even when matter collapses into black holes or energy disperses into faint cosmic background light. One of the most surprising ideas in contemporary cosmology is that the universe behaves like a system that preserves information perfectly. Black hole thermodynamics, holographic principles, and quantum entanglement all point to this stubborn persistence. Even when matter falls into a black hole, the information describing it does not vanish. It becomes imprinted in subtle ways on the boundaries of space-time. Thinking about this persistence feels like imagining a book where every word ever written remains somewhere in the margins, even if erased from the main pages. The story may shift, pages may tear, but the echoes of every sentence linger faintly beneath the surface. The universe carries its own marginalia, quiet imprints of everything that has ever occurred. Some physicists propose that information may be stored on the cosmic horizon, encoded like patterns on a vast sphere surrounding the observable universe. In this view, the three-dimensional world we experience could be a projection of deeper two-dimensional information. This holographic idea isn't science fiction. It arises from precise mathematical parallels between gravitational theories and quantum field theories. Imagining existence as a projection is unsettling at first, but the longer you sit with the idea, the more elegant it becomes. A hologram is not an illusion. It's a different representation of something real. If the universe is holographic, then space, times, and matter are expressions of a deeper informational structure woven at the edges of the cosmos. Such a framework reframes our search for the beginning. Instead of asking where matter came from, we begin to ask where information came from. What encoded the earliest fluctuations? What established the laws that would shape atoms, stars, and consciousness? These questions drift away from explosions and into the quiet realm of structure, symmetry, and transmission. The more we explore this informational landscape, the more intertwined it becomes with quantum entanglement, a phenomenon where particles remain connected even when separated by vast distances. Entanglement shapes matter, energy, and even space-time. Some researchers believe that space-time itself may emerge from a vast web of quantum entanglement, linking all particles. Visualizing entanglement is like picturing a constellation drawn not across the sky, but through the fabric of existence itself. Invisible threads connect distant points, forming a network more intricate than any neural map. These threads do not travel, they simply are, binding the cosmos in quiet unity. Such unity hints at something profound. The universe might not be a collection of separate objects, but a single system expressing different aspects of itself. Separation may be an illusion born from distance and perspective. On a deeper level, everything remains intertwined, every star, every particle, every thought. This perspective carries a quiet, melancholic beauty. When you realize that everything is connected, even across impossible distances, it becomes difficult to feel entirely isolated. The loneliness of existence softens. The cosmos begins to feel less like a cold expanse and more like an unfolding conversation between countless interlinked parts. Another line of research, known as emergent spacetime, suggests that space is not fundamental. Instead, it arises from the flow of quantum information. In this picture, distances, directions, and dimensions are not basic ingredients, but consequences of deeper relationships. Space becomes a byproduct of connectivity, like ripples emerging from water rather than being water itself. Contemplating space as emergent evokes a strange tenderness. The emptiness we perceive, those vast stretches between galaxies, might be less empty than it appears. It may be the quiet surface of something deeper and more intricate, a delicate architecture formed from patterns we cannot yet decode. If space and time emerge from information, then the universe's beginning becomes an informational shift. Somewhere in the earliest instance, the relationships that define geometry crystallized. The universe began not as a location or event, but as a reorganization in the deeper fabric that underlies reality. A new set of connections formed, allowing space-time to appear. Thinking of the beginning, this way transforms the emotional tone of cosmology. Instead of a violent birth, we imagine a subtle rearrangement, something akin to a melody quietly starting in an empty room. The notes arise not from nowhere, but from the conditions already present, weaving together into something new and coherent. Such a transition suggests that the early universe may have been humming with informational tension, fields poised on the edge of expression. The moment expansion began, that tension released, spreading patterns outward like frost, crystallizing over glass. Everywhere the frost touched, structure emerged. Modern experiments exploring quantum gravity, entanglement entropy, and holographic dualities continue to reveal fragments of this deeper structure. None provide a complete picture, but together they paint a universe that is far more relational than material. Reality becomes less about objects and more about interactions. This subtle shift casts a soft shadow over our assumptions. If relationships define reality, then the universe's expansion may be the growth of a network, not the stretching of empty space. Every new interaction, every connection, every entangled pair contributes to the ongoing weaving of space-time. The idea brings a gentle ache, an existential tenderness. We often think of the universe as indifferent, yet its very structure suggests intimacy. Everything touches everything else, albeit in ways we cannot perceive directly. Beneath every distance lies connection. Beneath every silence lies memory. Some theorists extend this perspective by proposing that consciousness might be related to the same informational processes that generate space-time. Not that the universe is aware in a human sense, but that the same principles shaping reality might also shape awareness. In this view, consciousness is not an exception to nature, it is one of its expressions. Entertaining this possibility encourages a softer approach to existence. Instead of standing apart from the universe, we begin to see ourselves as participants in its unfolding. Our thoughts, emotions, and experiences might be small ripples within the vast informational ocean that gave rise to stars and galaxies. As these ideas intertwine, they point toward a subtle insight. The universe's beginning might not be a place where physics stops, but where it deepens. Instead of being the edge of understanding, it becomes the doorway to a richer, more intricate reality, one where information, connection, and emergence shape everything. And in the quiet spaces between those thoughts, a new thread begins to glow. Something older than particles or space-time, hinting that the true nature of the beginning may be more elusive, more delicate, and more astonishing than any equation has yet revealed. There comes a point in exploring the universe's origins when the science becomes inseparable from something quieter, almost emotional. The deeper we look, the more we begin to sense that the universe is not simply expanding outward, it is expanding inward as well, into the recesses of thought and meaning. As the galaxies drift farther apart, the mind drifts deeper into questions that have no precise answers, only gentle echoes. Some thinkers suggest that the universe's vastness shapes human awareness. The sheer scale, the silence, the absence of edges, these qualities invite introspection. When you contemplate billions of galaxies fading into darkness, something loosens inside you. The ego softens. The urgency of daily concerns dissolves into a broader serenity, as if the cosmos were reminding you that your existence is both fleeting and extraordinary. The most distant galaxies observed by the James Webb Space Telescope appear as faint red smudges, ancient light stretched thin by expansion. They look fragile, almost ghost-like, yet each contains worlds, stars, and histories beyond anything we can imagine. Seeing them is like glimpsing memories that the universe barely holds on to, the faintest traces of a story written long before Earth existed. Gazing at those distant glimmers feels like walking through an abandoned cathedral lit only by candles. Every shadow seems to hold a secret. Every flicker feels like a whisper from something older than language. Even silence feels inhabited. The overwhelming immensity becomes strangely intimate, as though the universe were leaning in close rather than drifting away. As space expands, more galaxies slip beyond our cosmic horizon. Not because they vanish, but because light can no longer bridge the widening distance. Entire realms of creation fade from visibility slowly and permanently. The universe is not shrinking, but our view of it gradually becomes smaller. There is something bittersweet about this, an unhurried goodbye written into the physics of existence. Some astrophysicists describe this future as a gradual dimming. Over unthinkable stretches of time, fewer galaxies will remain visible from any one location. Stars will appear lonelier. Cosmic neighborhoods will grow isolated. The night sky, which today glitters with thousands of points of light, will eventually offer only a faint handful. We live at a rare moment when the universe is still bright. Imagining that distant future feels like picturing the last embers of a once mighty fire. The glow persists, warm and comforting, but the wood has burned low. The air grows cooler, the light stretches thin. You know the flame will remain for a long time, but not forever. There's beauty in that impermanence, even a calm acceptance of it. Long before everything dims, stars will continue living their cycles, igniting, burning, collapsing, enriching space with new elements. Eventually, though, star formation will slow. Gas clouds will thin. The universe will become quieter, more reflective. Structures will remain, but the vibrancy of creation will soften into a gentle stillness. Thinking about this future doesn't have to be unsettling. In some ways, it mirrors the natural arc of life itself. Everything bright eventually fades, everything complex eventually settles, but dimming is not erasure, it is a transition. The universe has already gone through countless such transitions, each leading into a new form of existence. Even now, remnants of past cosmic generations drift around us. White dwarfs, neutron stars, and black holes carry the memories of suns that once burned fiercely. They are relics, but not lifeless. Each one continues shaping the space around it, bending gravity, channeling energy, whispering stories of what came before. Black holes in particular evoke a strange mixture of fear and fascination. They are remnants of stars, but they behave more like deep wells carved into the fabric of space. Everything about them is extreme: density, gravity, curvature. And yet, at their boundaries, information persists. Hawking radiation slowly leaks energy away over eons, allowing even these titans to fade eventually. Imagining the final moments of a black hole feels like picturing the last note of a song dissolving into silence. A slow thinning of presence, a soft unraveling, until nothing remains except the memory encoded in the universe's deeper structure. Even collapse becomes a form of release. As everything spreads apart and cools, time itself seems to stretch. The pace of cosmic evolution slows. Galaxies drift like old ships navigating an endless ocean. Their light grows redder, their motion quieter. The universe becomes contemplative, almost meditative. A vast field of stillness, punctuated by the faint glow of ancient stars. This inevitable separation invites a gentler reflection. If everything drifts apart at large scales, what keeps meaning from dissolving? The answer seems to lie not in distance, but in connection. Even when galaxies move away, the physics that shaped them remains shared. Every atom follows the same rules. Every particle obeys the same constants. Connection is baked into existence. Recognizing this shared foundation brings a comforting paradox. We are small, yes. Our lives are brief, but we participate in patterns older than galaxies. The atoms inside your body once drifted through stellar winds. The calcium in your bones was forged in a dying star. The oxygen you breathe was born in ancient fusion. Your existence is a continuation of cosmic memory, and memory itself is a theme that reverberates through modern cosmology. The cosmic microwave background is the universe's earliest preserved light, a fossil of the time when atoms first formed. It's as if the universe kept a photograph of its childhood, a faint, grainy portrait that scientists continue to study with reverence. That light, stretched across the entire sky, carries imprints of the earliest fluctuations that shaped everything. Tiny temperature variations, too subtle to feel yet profound enough to define the large-scale structure of the cosmos. It is a message from a moment we cannot revisit, but can still hear through its echo. Listening to that echo feels like discovering a letter your past self wrote before you understood who you would become. The handwriting is shaky, the ideas are young, yet the message contains seeds of everything that followed. The universe remembers itself in that same way, through subtle patterns preserved across billions of years. As time passes, even that ancient glow will fade. Photons will stretch beyond detectability. The universe will continue expanding, cooling, dimming, but the memory will remain etched into the deeper informational structure underlying reality, just as the thoughts, emotions, and moments of your life leave traces in the architecture of who you are. There's something tender in this parallel. Cosmology and introspection begin to overlap. The universe, unlike a mind, carries its history forward. It forgets nothing, even when the visible traces disappear. The past is absorbed, not erased. The emotional weight of this realization settles like soft dust. You start to sense that the universe's story is not one of loss, but of transformation. Even as things drift apart, structures evolve and light dims. The underlying fabric remains active, full of possibility. Nothing is wasted. Nothing is truly gone. As the darkness deepens, a quiet insight emerges, one that doesn't shout, but gently invites reflection. The universe may someday fade from view, but its unfolding carries patterns we are only beginning to recognize. Those patterns point towards something deeper than light, deeper than matter, deeper than time itself. Something waiting quietly as the next layer of the story unfolds. Some questions linger not because they have no answer, but because they require a different kind of listening. The origin of the universe is one of them. Each new theory seems to illuminate a new corner of the mystery, yet the center remains elusive, retreating just beyond reach. It's a puzzle that doesn't resist understanding. It invites patience, the kind of patience that accepts depth without demanding closure. Various approaches in theoretical physics attempt to describe the conditions that gave rise to the cosmos. Each offers a unique lens: quantum gravity, string theory, emergent spacetime models, holographic dualities, yet none provide a full picture. Instead, they feel like chapters of a book whose ending hasn't been written. They complement each other without merging, hinting at a truth that may require an entirely new framework. Trying to weave these possibilities together feels like holding fragments of a shattered mirror. Each piece reflects a portion of the whole, beautiful, coherent, but incomplete. Only when you step back does a pattern emerge. Not the full image, but the knowledge that a full image exists. The universe seems to whisper that understanding is a horizon, not a destination. One idea suggests that our universe could have emerged from a higher dimensional reality. In this view, everything we experience, space, time, matter, could be the lower dimensional shadow of a deeper structure. What we call the Big Bang might be the moment a higher dimensional surface intersected with ours, igniting a new era of physics in its wake. Physicists working with brain cosmology explore these scenarios. They imagine vast membranes drifting within a larger multidimensional space. If two brains collided or brushed against each other, the resulting interaction could release immense energy, enough to create a universe. The story becomes less about emergence from nothing and more about interaction between worlds we cannot perceive. Envisioning these brains feels like picturing enormous sheets of shimmering fabric moving through a silent, infinite ocean. When they touch, ripples of energy cascade outward, forming new layers and patterns. Our universe might be one ripple, expanding and cooling as the energy diffuses through spacetime. The collision might be long past, but its echo remains. Another line of thought proposes that the universe might be a self-organizing system. Instead of emerging from a single event, it could arise naturally from the dynamics of information, energy, and entropy. Systems at all scales, from atoms to ecosystems, tend toward complexity when conditions allow. Perhaps the universe itself is the ultimate expression of this tendency. Considering this perspective reframes the beginning not as a spark, but as an inevitability. Given the right foundational rules, existence becomes the natural outcome. Entropy increases, patterns form, complexity blossoms. The universe didn't need a cause, it needed conditions. And once those conditions were met, expansion followed as easily as a river follows gravity. Other researchers argue that the universe might be part of a larger, infinite cycle of expansions and contractions, a cosmic heartbeat beating over unimaginable timescales. Our current expansion could be just one inhalation in a sequence without beginning or end. The Big Bang becomes a rhythmic transition rather than a singular creation. Thinking of the cosmos this way introduces a somber beauty. The universe breathes, collapses, reforms, expands again. Nothing is permanent, yet nothing is lost. Everything flows through phases of darkness and light, emptiness and structure. It mirrors the cycles of life in a way that feels almost poetic, though grounded in physics rather than metaphor. Another possibility suggests that universes might spontaneously arise within a vast, eternal quantum field. This field could be the true foundational reality, giving rise to countless universes within its fluctuations. Each universe would have different laws, different constants, different stories. We inhabit one branch of an infinite tree. Imagining that tree evokes a quiet nostalgia for worlds we will never know. Entire realities may bloom and fade without ever intersecting with ours. They remain forever hidden, Yet somehow their existence softens the loneliness of cosmic vastness. Our universe is special, but not alone. Some of the most striking approaches come from loop quantum gravity, where space-time itself is quantized. At the earliest instance, space may have been woven from finite units connected in a vast network. As this network expanded and reorganized, geometry emerged. The universe unfolded not from a point, but from relationships between nodes in a timeless web. Visualizing that web feels like imagining an infinite tapestry woven from threads of light. Before the design appears, the threads simply cross and connect. As the structure rearranges, patterns emerge, shapes, colors, symmetries. Space-time might have blossomed that way, weaving itself into coherence from pure relational information. These ideas all share a common theme. The universe is not a static thing, but an unfolding process. It grows, shifts, dissolves, reforms. Even the beginning behaves more like a transition than a boundary. When you chase the origin far enough, the landscape opens rather than narrowing. The edges blur, the mystery deepens. This openness is where the emotional weight gathers. We look for a starting point because beginnings help us organize our lives. Yet the universe may not offer one. It might offer movement instead, flow, transformation, continuity. The closest thing to a beginning might be the moment the cosmos became capable of remembering itself. Memory threads through every corner of cosmology. The cosmic microwave background preserves the earliest light. Nuclear abundances preserve the earliest reactions. Structures preserve the earliest fluctuations. Even the laws of physics preserve the earliest transitions. The universe holds its own history, even as it evolves beyond recognition. Recognizing this memory brings a subtle melancholy. Every observation we make is a glimpse into something that no longer exists. The galaxies we see are not as they are. They are as they were billions of years ago. The deeper we look, the older the light, the fainter the echo. We are always witnessing the past. Yet there is something profoundly comforting about that distance. The light still arrives. The echoes still reach us. The universe extends itself across time to reveal its story, even if the story is incomplete. We may never glimpse the true beginning, but we can feel its warmth in the afterglow left behind. Eventually, these ideas converge into a quiet realization. Perhaps the universe didn't begin abruptly. Perhaps it was always becoming, always shifting, always preparing the conditions for the expansion we now call the Big Bang. What we seek may not be a moment, but a transition that spans realms we cannot yet describe. Sitting with this possibility invites a long breath. You don't need to choose one theory. You don't need to solve the mystery. The value lies in the contemplation itself, the gentle unfolding of understanding at the edge of human knowledge. And as this realization settles, something else becomes clear. The mystery of the beginning isn't fading. It is expanding, like space itself. Another layer waits just ahead, quiet and luminous, inviting us to step closer and listen as the cosmic story continues to open. Looking back at everything we've drifted through tonight, the universe feels less like a riddle to be solved and more like a long, quiet river carrying us through its memories. We followed ancient light, watched structure bloom from fluctuations, saw laws crystallize from cooling fields, and listened to the soft echoes of the earliest transitions. None of these moments gave us a single, definitive answer to how everything began, but together, they painted a picture of a cosmos that unfolds gently, layer by layer, like dawn leaking into a dark horizon. As your thoughts settle, you might notice a familiar sense of calm, something like the silence of night stretching around you. The universe began with silence, or with motion, or with a shift too subtle to name, yet somehow that same stillness echoes in your breath. There's comfort in realizing that the cosmos doesn't rush. It doesn't demand certainty. It moves with patience, forming stars over millions of years, shaping galaxies with unhurried grace, whispering its history across space as faint, ancient light. All the possibilities we explored, quantum fluctuations, timeless phases, symmetry breaking, cosmic cycles, holographic horizons, are not contradictions. They are reflections, each offering a glimpse into a mystery that resists being confined to a single explanation. The beginning may be older than time, younger than cause, or woven into dimensions we cannot perceive. And yet, for all its strangeness, the universe feels deeply familiar, as if some part of us recognizes its rhythm instinctively. There's a quiet beauty in accepting this openness. The fact that the universe might not have a precise beginning does not diminish wonder. It expands it. The cosmos becomes not a story with a single opening chapter, but a tapestry woven from transitions, each one carrying us deeper into a landscape both infinite and intimate. It reminds us that uncertainty is not emptiness. It's space to breathe, space to wonder, space to rest. As the night holds you, you might feel a faint connection to the early universe, the way light drifts, the way silence settles, the way everything expands softly into possibility. The atoms in your body once floated in stellar winds. The carbon in your cells was forged in ancient furnaces. You are not a spectator on the outside of the cosmos. You are a continuation of it, a quiet extension of an ancient story still unfolding. And if this journey brought you even a moment of stillness, or helped you drift into a gentler state of mind, I'm truly grateful you spent this time here with me. Small gestures help this calming space stay alive, so if you'd like to support it, feel welcome to leave a like and subscribe to the channel. It means more than you know, especially in a corner of the internet devoted to quiet curiosity. I'd also love to know where in the world you are listening from tonight, and what time it is there. Every comment feels like a tiny constellation forming across the screen, each one a warm point of light in this growing community of wanderers, thinkers, and quiet souls who enjoy drifting through the cosmos together. The universe may be expanding, and its galaxies may drift farther apart, but moments like this bring a sense of closeness, proof that connection isn't limited by distance. It exists in shared curiosity, in soft wonder, in the simple act of pausing together under the same vast sky. No matter how far the galaxies move, this feeling remains. So as you ease into the rest of your night, let your breath grow soft again. Imagine the early universe as a dim glow on the edge of silence, a whisper stretching across eternity. That whisper is still moving, still traveling through you, still guiding the unfolding of everything that will ever be. And as the final traces of it settle around you, know that you are part of this story. Not separate, not small, but beautifully woven into its quiet light. Wherever you are, and whatever the night looks like outside your window, may it feel gentle, may it feel spacious, and may the echo of this cosmic journey stay with you, like a soft pulse in the dark, steady, ancient, and endlessly patient.